Hi, I'm Robin Webster from Centiq. I'm the CTO there, and I've been working with HANA since 2011, helping customers support and manage those systems. And we've been particularly interested in the capacity of those systems, and I'd like to share with you what we've learnt about the impact of capacity on a HANA system. So first of all, what's the difference between HANA and a traditional database? With a traditional database, you have some memory and you have disk. And as the system grows, you have a choice. You can archive, take data out of the system, or you can just buy more disk. And as archiving is pretty tricky, you have to make business decisions. Lots of people just keep buying more disk. Now HANA comes along and it's an in-memory database, so you need a lot of memory. You still need disk, of course. And when you've got more data, you've got that decision again, do I archive? You don't just add disk, of course, you need to add memory. And memory is expensive, so the cost per terabyte is much more than the cost per terabyte here. So, how big does the system need to be? Well, you could be fooled to thinking it's equivalent amount of memory to the amount of space you need. But unfortunately, it's around about half of it is how much data you'll get in that system, so about 50%. You actually lose about 2% from the bottom when you start the system up, and you lose another 3% to the OS. So you end up with a smaller amount of the system available for data in memory. We call this the GAL, Global Allocation Limit. So why is that lost, that 50%? Well, you've got computational requirements. When you're doing your queries, you need the space to fit the result in, but also it's the way that the database manages system. Every time it needs to re-index it, needs to compress it, it's rewriting the whole thing, and that takes a lot of memory to do that process. So what do we tend to see in practice? So if we see the growth of a system over time, when we see the in-memory value, you will see it grow over time. And then there'll be a point at which it will start to struggle and it will unload data. And this is where that 50% line comes in. If I just draw, what you will typically see is that erratic behavior will happen around the 50% mark. That's 50% of the memory in the system. So the other thing to note is that the actual data in the system, if you were to measure that, which we have lots, you'll see that that could be above, considerably higher than the actual in-memory value. So why is there that gap between here and here? Well, if we have a look at how the database is constructed, if you look at a single table, it's constructed of columns, and then it can be partitioned. And the database is able to load in a column partition. Maybe it loads in an entire column. So the in-memory component refers to the columns and partitions that are loaded, and the gap is associated with the elements that are not loaded. Now, depending on which system you've installed, whether it's an ECC system, SAP HANA, or one of the COPA accelerators, you will tend to see there that this gap is very, very narrow unless you carefully design your system to be partitioned appropriately, and then you can widen that gap. Why are we interested in widening that gap? Well, you are improving your ability to optimize the system because you're using less memory for the amount of data that you've got. Now, the more recent systems like S4 employ new strategies to reduce that overhead in memory. So they have data aging, and the idea is that it's using the same method of partitioning to improve the way that it uses memory. So the older data gets, it's put into separate partitions, so the older data is less frequently accessed and can remain on disk. So all of these things are going to be critical to keeping your system as optimal as possible. And this is going to be important because with a physical system that you're buying on premise, you might be planning for 5 years ahead, so it might need to be very, very big, very high capital cost at the beginning. And if you're planning for the cloud, of course, you're going to want to build in a strategy so you can have as small a system as possible during the early days and just grow it as necessary. And throughout this, and right at the beginning of setting up a HANA system, you need to be clear in your head, what is my data management strategy? Am I going to finally take on archiving? Am I going to use data aging? And what risks am I willing to accept? Because the downside of the ideas of data aging, if you still have ambitions to use that old data, then you are at risk of overloading the system. Because of course, if we look at these sort of different areas, you could say that here you've got as much, back here you can get virtually all your data in memory. So this is going to be highly optimized for performance. Here it's going to be very cost optimized, where you get occasional unloads of data. But over here you're going to have challenges because you're loading and unloading all the time because you haven't got enough memory. So this will impact performance greatly. So if you'd like to hear more about the challenges with running HANA, you want some help running your system, do get in touch. You can go to our website or you can follow us on Twitter. Thank you very much.